Good morning, grade 11s. Today we're going to do mathematical induction. This is a method in mathematics with two expressions can be proven equal. So you've got a left-hand side and you've got a right-hand side. And we can only do this when the variable can be a positive integer values. So let's make the assumption and say let's have a look at 2 plus 4 plus 6. That's series. And your last term will be 2n, and that will be equal to n bracket n plus 1, and we work with n elements of n, which is the natural numbers. So now we can test that. Let's take the left hand side. So if my n is equal to 1, the first natural number, then your left hand side will be 2. Your right hand side is then 1 bracket 1 plus 1, it's also 2. Now, if n is equal to 2, it means then you will have 2 times 2, that means it's 4. But remember, this is a series, so I must add the two terms together to get the sum, so that is 6. If I substitute the right hand side, it means then 2 bracket 2 plus 1, so it's 2 times 3, that's equal 6. Can you see left hand side is equal to the right hand side? And so I can carry on. If you take 5, it means then I must first calculate term 5. Term 5 will be 2 times 5, it will be 10. But with this series here, it means I must add the first 5 terms, and that's giving me 30. So that's term 1, 2, 3, 4, 5. Right hand side, you substitute a 5, and that means left hand side equals right hand side. So in this method, we can first going to prove is that we're going to use n. So this is my method of mathematical induction. So you prove the statement it's true for n equals 1, or the given starting value. Most of the time we're using n is equal to 1. So here the left hand side and the right hand side must be taken separately, and this is very, very important. This is your method you must follow with mathematical induction. So you start and you work with the left hand side and the right hand side separately. Second step, accept the statement is true for n equals k. You write it down because you get a mark for that. Thirdly, you prove with the use of number 2, so that means that you use n equals k, that the statement is also true for n equals k plus 1. So the left hand side and the right hand side must be considered separately, and then you do that equally. To get the left hand side, you take n equals k and you add the k plus nth term. So that's your left hand side. To get the right hand side, you substitute into the place of n, you substitute k plus 1. And then the right hand side will be equal to the left hand side. And then you must always write this little sentence. So this you must learn off by heart. The equation is true for n equals 1. If it's true for n equals k, it's also true for n equals k plus 1, and therefore true for all natural numbers of n. And always write this down at the end of your proof. So step 1 is you substitute 1 into the left hand side and the right hand side separately. Then you write down, except the statement is true for n equals k. Then you substitute the k into the left hand side. Right? And then you say, let this also be true for n k plus 1. And then you do the right hand side. And then thereafter, you write down the sentence. The equation is true for n equals 1. If it's true for n equals k, it will also be true for n equals k plus 1, and therefore true for all natural values of n. So you get a mark for that. So that will be for all your mathematical induction sums. Okay, let's do an example. So if you have a look at this one, so we've got 2 plus 4 plus 6, that's a series. So you add the terms, and the last one will be 2 to the n. And you must prove that that is equal to n bracket n plus 1 for all natural numbers. Now step 1 is where you use n equals 1. So you use the left-hand side to find the first term. So that means it's 2 times 1 will be 2. Then you do it separately. The right-hand side, you substitute 1 into there, you get 2. So this means then the left-hand side, right-hand side will be true for all natural numbers n equals 1. Step 2, you write this down. Except the statement is true for natural number k. So that means into the place of n, you substitute a k. So we accept that it's true. So you write your 2 plus 4 plus 6, but now into the place of n, you put a k. Into the place of n, you put a k. Right, so that's step 2. You accept that that's true then. Step 3 is then, now you look at n equals k plus 1. So now you do it separately. So the right-hand side, you substitute n, k plus 1 in the equation. So the right, you can either start right or left-hand side. So right-hand side is then n, so that will be k plus 1, and that is n plus 1, so that's k plus 1. So if I simplify that, I've got k plus 2, that one stays then k plus 1. So that's your right-hand side. Your left-hand side is then the 2, the 4, the 6. To the place of n, you substitute then 2k plus 1. So that was your 2k, and then you get 2 bracket k plus 1. You substitute the n, k plus 1. So if you take that in consideration, can you see the first part? The first part is equal then to k plus 1. That's your step 2. And then you add 2k plus 1. So if you look at that, you've got a common bracket there. So you factorize, and then you put the k plus the 1, the 2, and then your left-hand side is equal to your right-hand side. So you don't have to multiply out. And then your step 4 is then you write the sentence. The statement is true for n equals 1. So if it's true for n equals k, it will also be true for n k plus 1, and consequently true for all natural numbers of n. And this is then your mathematical induction.